So I always find people get confused when I say, yeah, the signal goes over a 20 megahertz band in the 2.4 gigahertz band. And they're like, whoa, what does that mean? So the best thing to do is to take a look at a spectrum analyzer. So that's what we're going to do now. And at the end of the demo, you should feel pretty good about what a channel bandwidth is, because I'm going to show you my 802.11 operating on a 20 megahertz channel. And we're also going to look at some different signal profiles, and you're going to see other signals operating in the 2.4 gigahertz band along with my Wi-Fi wireless LAN. In this demo, I want to take a look at one of my favorite tools, Channelizer, and what I'm going to do is I'm going to be using a wireless adapter, and I brought up here a website of MetaGeeks, and you can see up here the different types of adapters. So I've plugged one of these adapters in, and I'm actually running Channelizer 4. So let's take a look at that now. So I've brought up the Channelizer tool, and you can see already that it's starting to pick up signals in the 2.4 gigahertz band. Now, how do I know this is the 2.4 gigahertz band? See here is displaying the different frequencies across the 2.4 gigahertz band. Down here you can see the actual networks that it's discovering, and you can see here's Avril's network. I have one access point on channel 1, and you can see I've got security of WPA2. Over here you can see I've got a second access point. Now this is an 802.11n that's operating on a 40 megahertz channel, so it's going across channel 11 as the primary and channel 7 as the secondary. So whereas this is a 20 megahertz channel, this one here is a 40 megahertz channel. This is my network operating in the 5 gigahertz band up on channel 36, and this one here, if you go across, this is actually an ad hoc network, and we'll talk about the difference between ad hoc and infrastructure later on. If I look here at the data rates, I can tell just by looking at the data rates that these are all 802.11n, because A and G only go up to 54 megabits per second and B only goes up to 11 megabits per second. So let's take a look at what these look like. I'm going to click on Avril's networks here, and we'll display those. And here you can see this is channel 1, and here you can see this is channel 7 and 11. And if you don't believe me on the channels, I can change the view here and just say, oh, rather than having frequencies displayed, let me display the channels. And now you can see. And so the main thing I wanted to point out to you here was that this is deploying on channel 1 and is using a 20 megahertz band. See how it's spreading that signal over a 20 megahertz band? Whereas up here, in the higher part of the 2.4 gigahertz band, I've got a 40 megahertz channel, so it's twice as wide, operating on channel 7 and 11. So it's added those two channels together. Now I can also here display the iMac here. I turn that one on, and you can see that's deployed on channel 5, and you can see that it overlaps with my other access points. And so when you see that, you know there's going to cause interference with each other. So let me just turn the iMac off. So the other thing I wanted to show you was the kinds of signatures. Now I can tell by the square shape of these signals like this square shape here, that this is an ERV-DM signal. And so different radios have different signatures, and so by looking at the signatures I can kind of tell what might be transmitting. So if I come down here a bit, here you can see the types of things. See, this is an 802.11b radio, gives me this kind of curved look to it. If I come down a bit more, here's some examples here of a cordless phone. This is an OFDM signal. This is Motorola's Canopy, and that uses an OFDM system different from 802.11, but similar signal because it's still an OFDM structure. And so different radios have different patterns. And so here again, come down a bit, I can start to see videos, etc. So I can literally profile different pieces of equipment that could be operating in my band. So if I click over here on this button here, I'm going to display what else is happening in the 2.4 gigahertz band. So you can see my 2 access points, but now you can see, wow, what is this thing jumping all over the place? And I could look down here at one of these profiles and say, well, gee, does it fit with one of these profiles? And so you can come down and say, well, you know, is it a cordless phone? Yeah, could it be this AV transmitter? If you come down a bit more, you know, oh, you know, could it be a headset that's going on here? Now, to keep you out of suspense as to what this actually is this is actually a proprietary technology. And so this is a technology which would be very difficult to actually determine what it is based on the signatures, because this is actually proprietary and it's not a known signature. This is actually my solar power system. And I run a solar power system in my home, and it is transmitting updates as to how much energy I'm generating, and so that's what you're seeing in the band. And if I look here at my y-axis, you can see the power level that is transmitting at as to kind of the impact it's going to have on my Wi-Fi system. Remember that the way Wi-Fi operates is it's going to listen, and it will only transmit if it doesn't hear any noise in the band. So let's turn off my signatures there and go back to my network table. So I just want to close that. I don't want to save the file. And again, to pick up those signals, all I've done is I've added in my wireless adapter. I'm running Channelizer 4 as my application, and I'm picking up signals in the 2.4 gigahertz band, and you can see that 802.11n uses a 20 and a 40 megahertz channel in the 2.4 gigahertz band. So the main thing here is to understand the frequency band that I'm looking at, and then that my signals actually operate across a band. In the case of Wi-Fi, that's a 20 or a 40 megahertz channel. So I hope you really found that valuable, because a lot of people really get confused between what's a channel band and what's the frequency band and what does all that mean. So play with this, take a look what's happening in the band. You can take your tool, your wireless adapter in the laptop, and walk closer to the source of interference. You're going to find those signals will get stronger. As you move away, they get weaker. So play with these tools. And again, I'm not recommending Channelizer and the Y-Spy tool. This is simply the tool that I use because it's very, very easy to use, is simple to understand, and it's a really good tool to get yourself going. I use it a lot when I go to conferences just to explain the basics of frequency channels and channel bandwidths. So well done in getting through this section.